Hi, grade 11s. Let's solve for x, but let's do so for this third equation. A good place to start is to rewrite this equation. So 5 minus x, square root of 5 minus x is x plus 1. So whenever we're dealing with third equations, the first thing to do is to isolate the square root or the third, and in this case, fortunately, the third has already been isolated for us. The second step then would be to try and eliminate the square root in order for us to solve for x. Remember, x is within the square root, and in order for us to eliminate the square root, we need to take the square, because you can think of the square root and the square as opposites, so essentially they would cancel each other out. So what you're left with is 5 minus x is equals to x plus 1, x plus 1. If I'm to expand this and further simplifying, the right hand side should give us x squared plus 2x plus positive 1. Just going to take these two to the other side of the equation. We do notice a variable with a square, so essentially what we're dealing here with is a quadratic equation, and when we are presented with quadratic equations, in order for us to solve them, we need to write them in standard form. And writing them in standard form would mean that the quadratic equation should have a 0 on one side. That is why we want to move these positive 5 and minus x to the other side. So essentially it would be 0 x squared plus positive 2x plus x plus 1 minus 5, and simplifying that, cancelling or adding like terms, should give us the following. 0 is equals to x squared plus 3x minus 4, and if we are to factorize this, 0 should be equals to x negative 4 plus 1. The product of these two terms, negative 4 and positive 1, gives us the last term, and the sum of the two terms does not give us positive 3, so we need to just change the signs. This should be positive and that should be negative. So now if you take the sum of positive 4 and negative 1, you get the middle term, and if you take the product of negative 1 and positive 4, you get negative 4. Therefore, solving for the quadratic equation, we get x to be equals to positive 1 or x to be equals to negative 4. Let's test if these solutions are valid in the original equation. If I'm to substitute 1 there, here, and 1 there, I would get 5 minus 1, which is 4, and the square root of 4 is 2, and 1 plus 1 is 2. So that is a valid solution for the original third equation. Now let's test negative 4. If I'm to plug negative 4 in there and negative 4 in there, on the right side I'll get 5 minus minus 4, which is 9, and square root of 9 is 3, and negative 4 plus 1 is negative 3. So the left hand side is not equals to the right hand side, and therefore negative 4 is not a solution. So the only solution to the third equation is x should be equals to positive 1.